Hello everybody, Clifford Williams here from 8 Ions to go over phase 1 of DevOpsing with Python. In our first video, in env setup, we downloaded and configured VirtualBox, imported an OVA file, and booted up our working image. Now it's time to build out some working hosts to connect to and take a look around our environment. Originally this was all set up ahead of time, but I found that this was a great opportunity to cover some of the functionality of Fabric, so I decided to ship the OVA without all these steps run, and this way we can walk through it programmatically. So here in phase 1, what we're going to do is poke around the environment a little bit, find out exactly what's set up already for us, and then we will write some Fabric tasks, build out virtual hosts to use with Salt and Ansible, and provision those virtual hosts using Fabric. Here we're logged into our VM from the first video as student00. Again, the password is student00.password. The first thing to check out here is probably Python. If I type Python, you can see that we're running version 2.7.9. And by the way, this isn't the system Python. You can see that we're using a system called PyEnv. We're not going to go into too much detail about PyEnv here in this video. I encourage you to check the documentation and look it up in your own free time. For now, let's see what modules we have installed. Now let's take a look at our shell. We also have Git installed. It's probably a good time to go ahead and start playing with some Fabric tasks. Before we do that, let's make a directory to hold our source code. I like to call mine prog. And in here, we can keep our code. Since we already have a project started on GitHub, let's go ahead and check that out. Okay, here we're on the GitHub page for DevOpsing, which is the name of this project. Here we can see that there's a repository called Workshop00, which is the one that we're working with. And all we need to do is check it out. I'm going to use the SSH checkout because I can use this to do commits back to the project. You might be fine using HTTP or HTTPS. It just depends on what you want to do. So while I'm in my prog directory, I'll do git clone and the clone path. And now we've got the project checked out. Now before I start working with this code here, or with this repository, I should probably show you tmux. Anytime I start coding, which I tend to do from the terminal, I like to start up a tmux session. Tmux stands for Terminal Multiplexer. And when we launch it, we see that we're put back at a shell prompt. Tmux allows me to run multiple windows within a given terminal. So you can see here if I do an ls-l, that's the listing of where I am currently. And if I hit the meta command key and type C, I get a brand new window with a new terminal, with a new shell, and I can do ls-al. Now I did that so that you can see that the output is slightly different, and if I switch back and forth between terminal windows, you'll notice at the bottom that the asterisk jumps from the one labeled 0 ZSH to the one labeled 1 ZSH and back. Now, not only can you have multiple windows, but you can have multiple panes in multiple windows. So if I hit the meta command, which for me is Control B, and then hit double quotes, I can do a horizontal split on the screen. And each pane can be subdivided into other panes. So here, while I'm in this one, if I do meta command and the %sign, I can get a vertical split as opposed to a horizontal one. And all the while, my other terminal is still, all the while my other shell is still there on the other window. So using tmux can save you a lot of time, especially if you have an editor open and you need to look up commands. Sometimes you might be working on a file and maybe you don't remember where ZSH is installed. With tmux, you can simply open up a new shell, find its location, and then go back and finish editing. And now you're in business. All right, so now we're ready to start playing with Fabric. You'll notice that we already have Fabric installed. We're running version 1.10.1. And I should mention our hierarchy here. Just installed the tree utility so that you can see this. At the top of our repository, we have our license file and our README. And this video is called phase 1, so we have a phase 1 directory. SOW is statement of work.txt, where if there are challenges or extra bonuses, they'll be listed there, as well as a description of what is covered in the video. Next, we have Fabric. If we had code for Ansible or Salt in phase 1, we would have a directory called phase 1, and then, we would have a directory called Salt or Ansible under phase 1 that had the code for that particular system. In this case, since we only have code for Fabric, that's the only one that we'll see. The phase 2 video will have a Fabric directory, a Salt directory, and an Ansible directory. Okay, this is a very basic example Fabric file. To invoke Fabric, you simply run fab. Fabric looks for the presence of a file called fab.py. You can override this with the -f option and specify a different file to use. For now, we're going to move our fab file to fab.py. You can also execute fab --list, and by default it will list all of the available tasks in the fab file that's specified, or fabfile.py by default. Let's go ahead and open up an editor in a top window and then run commands in a window below that. We'll use Vim to enable syntax highlighting. Fabric's API is accessible as a standard Python module. Here we import it using the wildcard. We've created a Python function called simple hello that simply prints out hello. Next, we have variable hello, which actually takes a parameter, and we'll show how we pass a parameter on the command line. Then we have this where am I, which uses one of the operations that comes along with the Fabric API called run. So let's go ahead and see what happens. Would help if I were in the right directory. So we can see that every function that we have in the fab file is listed here as an available command. When we call simple hello, we get hello, which is what we would expect, considering that there's just a print hello statement up there. If we call variable hello, we get hello Joe. But what if we wanted to say something other than Joe? You can pass parameters to Fabric commands using the colon. Similarly, you can name your parameter. Just make sure that it corresponds to what the function is expecting. The last one is a bit different because where I am uses run, which is part of the Fabric operation set. And when we invoke it, we get prompted for a host to specify. Fabric was designed to execute commands successively over a number of hosts. In this case, we're just going to be doing things locally, so we can use localhost. Here we have a fatal error. We tried to run the pwd command, but it's complaining because we don't have this command that it's expecting, bin bash. Now, this is actually a pretty common problem for software that's expecting to be run on a system that's set up like Linux, where on many Linux systems, bash is installed. Frequently, it's the default shell, and it's usually installed in the base of the system, meaning at /bin. Most Unix systems don't have bash installed, and if they do, it's usually not in that location. But because of the prominence of Linux, how popular it is, frequently you'll see software that just expects bash to be there and to be in that location. Luckily, with Fabric, we can override this behavior. Since Fabric is just basic Python, we can specify our shell using the included env variable before we invoke anything else. Okay, here we've specified the path to bash, which we did have installed. It's just in a location other than what they were expecting. So again, we get prompted for the host. But these commands are pretty simple. Here's a useful one. And we can see that for host name, we get the output of student 00, which corresponds to the actual host name. This will come in handy later when we actually have our other hosts set up. Speaking of other hosts, let's take a look at what we'll be using for that. Since we're on FreeBSD, we'll be using Jails. Jails is a FreeBSD system for doing lightweight virtualization, where you don't have the overhead of running a kernel and a full machine. All you do is instead you have process and resource isolation and virtualization at the file system level. We currently have no Jails. We currently have no active and running Jails. You can run the JLS command and see that there's nothing there. JLS is actually a native tool to FreeBSD for doing this. We're going to use a wrapper called Warden. We won't be going into all of the details about Warden and how it's used. There's information available on the web about Warden. We'll provide links at the end. Okay, one thing we want to do is make a jail. And since I'm running tmux, I can look at how to do that in one window. And actually craft the command in another window. We can make a few assumptions here just because we're in an isolated environment. Hopefully you would write this in a way that would be more robust, but for the sake of this workshop, it's okay to make a couple of assumptions. Here we call local, which is another operation included with the Fabric API. I recommend that you take a look at the Fabric API and find out about all of the operators that it comes with. Some of the ones that we will be using and that are very common to use are local, which will run a command on the local system, run, which will run a command in the shell of whatever the remote system is, sudo, which will do like run, but use the sudo utility so that you can elevate privileges, get, which can download files, and put, which can upload files. Okay, now what we've got here is a string that is formatted with two parameters passed, hostname and host IP. So when this actually gets processed, this little section here will get replaced with the host name, and then the IP address will be over here. And that makes our command, which we're calling as a parameter to local. Let's go ahead and run this and see what happens. Now, if we take a look at our network block, using the ifconfig command, we will notice that we're in the 10.100.182.10 range. So we need to pick a host that's also in that range. We'll just go ahead and start at .11 and number sequentially. Now, if you recall, we can use the colon to pass a parameter to one of the Fabric tasks. So for the host name, we'll call this one jail00. And we can actually use a comma to separate parameters. So we will call, or we will supply the IP address of 10.100.182.11. Now, when we ran this, we got an error. It says this command must be run as root. We executed it using the local command, but we do have sudo available. So this time when we run the same command using the operator sudo from the Fabric API, notice that we are prompted for a host. Local doesn't expect to have a host to connect to, so if the task that you're executing only has calls to local in it, then you probably won't get prompted for a host. But because run, sudo, and a few others expect to be run on another host, you will get prompted if you don't supply one. There are a few ways to get around this. For now, I'll just type in localhost. And there you can see that we are now building our jail. It takes a while because it has to download packages and actually build the environment. If you're not connected to the internet, this process won't work for you. Once it's done, we can execute sudo warden list and see that we now have a jail there. Just coincidentally, if you run jls, which is the jail list command from FreeBSD, you won't see anything there. There are a number of reasons why that is. I won't go into it. Just know that you should be using the warden utility to list and manage your jails. So now we have one jail. We actually need 9. So I can do this again. Simply going back, change this to a 1, change this to a 2, run it again, and again put in localhost. Actually, you know what? Let's say I'm sick of putting in localhost. So use the -h option, give it a list of hosts. In this case, it's a list of 1, just has localhost, and then it goes off and does everything. And now we have our second host. So I could keep going on like this until I get up to number 9. But there's got to be a better way. So rather than perpetuate this madness, let's do something a little bit more Pythonic. Since Fabric is just regular old Python, we can use Python data structures like dictionaries. Okay, now we have a variable that gets set called jails, and we can use this to do something like this. Make jails Okay, here what we have is a Fabric task called make jails. Make jails simply takes the jails dictionary, lists out its items by key value pair, and then calls the make jail command, singular, passing it the key, which happens to be the host name, and the value, which happens to be the IP address, and those correspond to the parameters that make jail is looking for. So let's go ahead and run this and see what happens. We don't need to specify any parameters since make jails doesn't require any. It has the dictionary. So it looks like we're off to a good start. It's apparently processing the dictionary and creating jails the way that it had been before. So let's just see if we end up with success in the end. I should mention that if you're on a slow internet connection, this part can be torture. Each jail is over 100 meg, probably around 200 meg in total. We're building 9 of them, so that's just under a gig. One thing you can do as a bonus is figure out how to build one jail and then clone it, changing what you need to have the new clones come up as proper new hosts, and not download everything to build a jail for every jail that needs to be created. Okay, so we can see that we got an error here. And if you recall, we created a few jails before we created the dictionary, and when we got to the point in the dictionary where we hit the other jails, we got this error. This actually brings up one of the key differences between Fabric and tools like Ansible and Salt. Fabric is not designed to be idempotent or idempotent. Basically, idempotence means that if you have a command or a process or whatever, it will only do the work that it needs to do to get to the desired expressed state. A good way to think of this is if you have a bunch of files that need to sit in a particular place, right? You can write a script that will put the files there. If it's a very naive approach to solving this problem, you'll simply overwrite the files if they already exist because you only care that the files are actually there. A slightly more sophisticated approach would be to say, hey, if those files already exist, don't overwrite them. An even more sophisticated approach would be to compare the files and see if they match. And if they don't match, overwrite them. And that's kind of the idea behind idempotence or idempotence. Let's not waste time doing work that doesn't need to be done. We can verify whether something is in the desired state. If it's not, let's do the work. If it is in the desired state, let's not screw up anything by redoing the same work. So anyway, let's do a list of our jails. And we see that we got through as far as where we encountered the error. We specified 9. We only got, we specified we specified 10. We only got to 8. So what we can do to make this right is because of its simplicity and its ability to run, commands on many hosts sequentially, Fabric is used for deployment recipes, and this is a deployment recipe of a sort. You can string a bunch of commands together, just like you saw. Make jails uses make jail in a for loop to do things. One of the first things that many people learn to do with Fabric is to do a deployment, and usually the second thing that they learn to do is to undo their deployment, because if something breaks, Fabric's lack of an inherent idempotent model means that you need to be able to roll back to a known state. Occasionally, infrastructure is such that you can wipe away whatever didn't roll out successfully and just reapply the task or the deployment. But generally, the second thing someone learns how to do with Fabric is undo what they just did. So we have delete jail here, and we're going to make it work pretty much like make jail, except that we only need a host name because we don't need to use the IP address when we're removing the jail. All right, let's see how our shiny new delete command works. If we execute it without passing it the expected parameters, we get a typical Python traceback. Let's go ahead and, let's list here. So these are the hosts that we have available. Let's delete jail07. Localhost. And let's list again. All right, looks like it did the job. So let's not go ahead and do all of these by hand. Let's create a command that will iterate similarly to the way we did with make jails. Similarly, this one won't need to take a parameter because it's just going to use the same dictionary that we had specified before. All right, let's see how it goes. We will execute fab delete jails, localhost. And we hit an error. It says that there's no such jail. So we can see that when there's a problem with things being there that shouldn't be there, or things not being there that should be there, we can have problems. There's actually a way in Fabric to say, don't worry about these errors, just continue. I will leave it up as a challenge to you to figure out how to do that. You can find the documentation at docs.fabfile.org. We will include links to documentation at the end of the video. For now, I am going to go ahead and cheat by modifying our dictionary. Okay, now that that's done, let's go ahead and rerun our make command. Now, again, this will take a while because we've got 9 jails to make. Oh, wait, we've got a problem. I forgot to change our dictionary back. So let's go ahead and delete these. It would help if we had the right name. Okay, now let's fix our dictionary so that we can get all the hosts in the make. Let's verify that we have nothing there. And let's run the make. While this runs, I'm going to start working on some of the other things that I know we'll need. Once we have our jails created, we'll have to do some provisioning. So, for instance, that includes creating a user, installing some software, all of that stuff. So let's first say that we want to install some packages. Since we'll be doing this in the jail, we're going to need to make use of the env shell that we used before. Except this time, instead of specifying bash, we're going to use the warden utility for starting a shell inside a jail. And now that we're done down here, I can actually show you what this command is. When I execute warden chroot jail 00, it tells me that the jail is not running, which that's another thing that we'll need to do. We'll need to start all of the jails. For now, we'll say that the way that we start jails, actually, let's hold it here. Let's make our command that starts the jails. Okay, here we have a function called start jails. Takes the jails dictionary. In this case, we're only using the key. We might use the value later, but for now it's just the key, so I'm going to leave it the way it is. And that issues the start command to actually have the jail start up. So let's see how that works. Okay, and what we're seeing here is the kind of startup output for the system booting. By system, I mean the jails. You can see that it's generating SSH keys, and we've got the console output. Now if I do a warden list command, we can see that status is set to running for all of these jails. Notice that auto start is set to disabled. Another thing I will leave to you is to figure out what auto start is and how you change it. So go figure that out. In our case, we have a function to start the jails, and they are currently running. So now if I do chroot into jail 00, you can see that it tells me I am root at jail 00. If I do W, I don't show up. There are a number of reasons for that. We won't get into it. One thing to notice is that when I run ifconfig, although the loopback interface is shown there, it doesn't have an address. I'm not going to get into jails and how the networking works here. Just know that by default, if you start up a jail in the way that we did, you do not have an address for loopback. So that can affect some of the decisions you make with regard to like how you set up your firewalls, what software you install, how you configure your software, etc. So we will exit our jail, and we will finish with the part that installs software for us. Now in FreeBSD, we use the pkg command to install software. There are others that you can use, but we'll just use pkg. We're going to install sudo because it does not come installed by default on a stock FreeBSD installation. We'll install ksh93 just because it's one of my favorite shells. We will install the system Python, and in FreeBSD, some of the components that come with Python are packaged separately. I'm sorry, some of the components that come with Python are packaged separately. We use the -y option so that we don't have to worry about getting prompted for something and needing to type in y to say yes. Let's go ahead and run this on a jail. Okay, and we got an error because I messed up this command. It's sudo warden space chroot, not /chroot. Okay, let's give it another go. And we can see that the packages are starting to be installed. So we will go ahead and let this finish for jail 00. And since I'm going to need to do this for the other jails, I'm going to go up to the top here, take jail 00 out of the dictionary, go back to the bottom, and think about what else we might need to do. So after we have packages installed, we will need to make a user. Okay, so here we are with our make jail user command. What we've got is something that sets our shell to the warden's chroot command. We call FreeBSD's pw user add command. We take as a parameter to the function in the first place the jail name and the username, and here we just substitute this bit of string formatting for the actual username. And then we set a password to be username.password, which is what we've been using so far. And so when we call this, we'll call this with student 00 so that our student 00 user gets created inside the jail. Okay, here we are with another thing that we will need, which is the ability to sudo. So once we have the student 00 user created, that user needs to be added to the sudoers file. So now rather than do all of these steps individually, let's go ahead and make a function that calls each of these, and we'll call it provision. Okay, let's look at what a provision jail does. We start off with the jails dictionary. In a for loop, we get the host name and the IP address. We call make jail user with student 00 so that we create our student user. Then we say install the packages that should be installed for this particular jail. And then push sudoers, meaning add our user to the sudoers file. All right, before we continue with running this, let's go ahead and delete the jails that we currently have. And then once they're gone, we will go ahead and run make jails. Then we'll start jails, and then we will provision jails. Back in a minute. All right, now we're clear. So let's make jails. And again, this will take a while, so I'll be back in a minute. Okay, it looks like we're done here. Let's go ahead and do a list. And we can see that we have our hosts created, and they are currently in the status of stopped. So let's start them. And we're seeing everything that we should be seeing, generation of SSH keys, general output from the system startup. So we'll go ahead and list, and we see that they are all running. This means that I should be able to SSH into a host, right? Except that my password didn't work because we haven't provisioned the box yet, which means that we didn't create our user, we didn't install any packages or anything else. So now, instead of start jails, we'll run provision jails. And as I'm watching this run, it occurs to me that we shouldn't be able to address these hosts by name because they're not in DNS and we haven't created host entries for them yet. So let's go ahead and do that while this continues to run. Okay, put is one of Fabric's operators, and in this case, we will need to create a file for it to move. We'll create the files directory. We'll put hosts inside the files directory, and because it usually works, remotely, the first path is the source path, and the second one is the destination path. We don't have to specify / and then the name of the actual file that it's going to. We can just say /etc and it'll take care of everything. Because writing to etc requires root privileges, we need to elevate to sudo or to the root user, and Fabric provides the facility of use_sudo. We set that to true, and it'll go ahead and give us the permissions that we need. So before we can use that, let's go over here to this free window. let's go ahead and push out a hosts file. Notice that the fab file that we're using is in our current directory. The path for put, if we use just a regular, a relative path, will be relative to the path from which we're invoking Fabric. So if I just say files here and inside files create a hosts file, when I run it from my current directory where the fab file lives, it will find the hosts file. Okay, now we've got a host file that we can push out to, well, actually to our local box. So we call push hosts, and I'll go ahead and specify -h localhost on the command line. All right, looks like we're done. Cat etc hosts, and that looks like what we need to see. At this point, we should be able to SSH into our hosts. We want to acknowledge or accept the SSH key, and then type in our password. Since we're SSHing in as the user student 00, we'll use the password student 00.password. There we have it. We're in. At this point, we've covered quite a bit. You should be able to SSH into all of your various jails. Feel free to poke around, and please do try to take up some of the bonus challenges. Learn about auto start and get that working with Warden and Fabric. Maybe make a single jail and then clone it using Fabric and do, make some of the changes that you need. Learn how to ignore the errors in a task execution. Or possibly make a meta command to run through everything that we created today. The code for everything is available on GitHub. There's the URL. If there are any corrections or updates, that code will be. If there are any corrections or updates, they will find their way into that repository. If you didn't, if you were trying to follow along and couldn't type something, don't worry about it. All of the code is there. You can just go there, grab it, and run the commands. Documentation for key pieces that we talked about today is available at these resources. And with that, I'd like to say thank you. I look forward to seeing you in the next video, where we will start digging in with Ansible and Salt.